Stop for a moment and look at any clock near you. Notice something strange. There are 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. That's 60 times 6. Why 60? Why not 10, like our fingers? Why not 100, which would be so much easier for calculations? The answer takes us back 4,000 years to the dusty streets of ancient Babylon, where mathematician-priests made a decision that still controls every clock, every watch, every timer on Earth. They chose a number system so brilliant, so mathematically elegant, that we've never been able to improve upon it. Today, we're cracking open Babylon's mathematical vault and discovering why the Sexagesimal system base 60 is one of the most ingenious inventions in human history, and why, despite living in a based-in world, we still can't escape the mathematical genius of ancient Mesopotamia. Welcome back to Math's Whisperer, where we uncover the hidden stories of mathematics. I'm your host, and this is Season 2. Episode 2. Picture Mesopotamia around 3000 BCE, between the Tigris and Euphrates rivers. The Sumerians were building the world's first cities, Uruk, Ur, Lagash. These weren't small villages, they were urban centers with tens of thousands of people, massive temple complexes, sophisticated irrigation systems, and international trade networks. Managing this complexity required mathematics. Serious mathematics? But here's the challenge they faced. How do you create a number system that's practical for trade, astronomy, geometry, and administration? The Sumerians tried several approaches before settling on something revolutionary. They chose base 60. To understand why this was genius, we need to understand what base means. We use base 10 decimal. We have 10 digits, 0 through 9, and when we reach 10, we start a new column. 10 tens make 100. 10 hundreds make 1,000. The Babylonians, who inherited and refined the Sumerian system around 2000 BC, used base 60. They had 60 unique symbols or combinations, and when they reached 60, they started a new column. Your first reaction might be, that sounds insanely complicated. 60 different symbols to memorize. But here's the clever part. They didn't use 60 completely different symbols. They used a combination of just 2 symbols, a vertical wedge for 1 and a corner wedge for 10. By combining these in different ways, they could represent any number from 1 to 59 within a single position. And then, like our decimal system, they used positional notation. The position of a symbol determined its value, just like how the 5 in 50 means something different than the 5 in 500. Now here's where it gets interesting. Why 60 specifically? The answer is beautiful. 60 is mathematically special. It's what mathematicians call a highly composite number. It has more divisors than any smaller number. Let me show you what this means. Practically, 60 divides evenly by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. That's 12 different divisors. Compare this to our based-in system. The number 10 only divides evenly by 1, 2, 5, and 10. Just 4 divisors. Why does this matter? Because in the ancient world and even today, you constantly need to divide things into parts. Imagine you're a Babylonian merchant dividing goods among partners. Split 60 items among 2 people. Each gets 30. Clean division. Among 3 people. Each gets 20. No remainder. Among 4 people. 15 each. Perfect. Among 5 people. 12 each. Still perfect. Among 6 people. 10 each. No fractions needed. Try doing this with base 10. Divide 10 items among 3 people. And you get 3.333 ... fractions. Messy. Complicated. The Babylonians created a system where fractions were rarely needed for everyday calculations. This was practical genius. But there's another reason base 60 dominated. Astronomy. The Babylonians were obsessed with the heavens. They tracked planets, predicted eclipses, and created detailed astronomical tables. They were the world's first serious astronomers, and they discovered something fascinating. Their mathematical system perfectly matched celestial cycles. The year has approximately 360 days, close enough that ancient peoples used this number. And 3060 is simply 60 times 6. This wasn't coincidence. It was mathematical harmony between their number system and nature. They divided the circle into 3060 degrees, with each degree subdivided into 60 minutes, and each minute into 60 seconds. This allowed precise astronomical measurements using their familiar base 60 system. When they tracked the movement of stars across the sky, base 60 allowed them to create tables with incredible precision. They could predict planetary positions years in advance, an achievement that wouldn't be matched in Europe for over 2,000 years. Remember that clock you looked at when we started? Every time you check the time, you're using Babylonian. Mathematics? That second hand sweeping around? It's counting in base 60. The minute hand? Also base 60. This 4,000-year-old system is so good, we've never replaced it. The base 60 system didn't stay in Babylon. It spread like mathematical wildfire across the ancient world. Greek astronomers, including Ptolemy, adopted it for their astronomical calculations. They inherited Babylonian astronomical tables and continued using base 64 measurements of time and angles. When Islamic scholars preserved and advanced Greek learning during the European Dark Ages, they kept the sexagesimal system. The father of algebra, used base 60 notation in his astronomical works. When Europeans rediscovered this knowledge during the Renaissance, they found a system too useful to abandon. Even as they developed new mathematical notation, they kept base 64, time and angles. Why? Because changing would require recalibrating every astronomical instrument, rewriting every navigation table, and retraining every sailor and surveyor. The practical benefits didn't justify the massive disruption. Plus, base 60 actually is better for these applications. Its divisibility makes calculations easier, not harder. Let me show you how beautifully base 60 works for time. An hour has 60 minutes. Why is this better than, say, 100 metric minutes? With 60 minutes, quarter hour equals 15 minutes exact, third of an hour equals 20 minutes exact, half hour equals 30 minutes exact, 2/3 hour equals 40 minutes exact. These divisions happen constantly in daily life. Meet in a quarter hour. The meeting runs 20 minutes over. Wait half an hour. Try this with a 100-minute hour. Quarter equals 25 minutes, okay? Third equals 33.333 minutes. Messy 2/3 equals 66.666 minutes. Messy. The Babylonians optimized for practical division, and it still serves us for millennia later. The most visible Babylonian legacy is in geometry. 360 degrees in a circle. Why 360? It's beautifully divisible. 360 divided by 2 equals 180 straight angle. 360 divided by 3 equals 120, easy to construct with compass. 360 divided by 4 equals 90. Right angle, 360 divided by 660. Equilateral triangle. Angle, 360 divided by 8 equals 45. Common angle, 360 divided by 12 equals 30. Another common angle. These divisions occur constantly in architecture, engineering, design, and navigation. The Babylonian choice of 360 makes all these calculations cleaner. Modern proposals to metric angles using gradients 400 to a circle or just using radians have never caught on outside specialized scientific fields. Why? Because 360 works too well. We need to appreciate how sophisticated Babylonian mathematics was. They could solve quadratic equations problems, like x squared plus 5x equals 6. They had methods equivalent to our quadratic formula, though expressed geometrically rather than algebraically. They created tables of squares, cubes, reciprocals, and even compound interest calculations. Banking and loans existed in Babylon, and they needed mathematics to track debt, interest, and repayment schedules. They approximated square roots with remarkable precision. A clay tablet from around 1800 BCE shows a calculation of the square root of 2 accurate to 6 decimal places. This is extraordinary for the ancient world, and they did all this in base 60, proving that their number system was sophisticated enough for advanced mathematics, not just basic counting. If base 60 is so great, why do we use base 10 for most things? The honest answer: convenience. We have 10 fingers. Base 10 is natural for counting on your hands. For basic arithmetic, the kind most people do most of the time, base 10 is simpler. You only need to memorize multiplication tables up to 10. That's 100 facts. In base 60, you'd need tables up to 60. That's 3,600 facts to memorize. For everyday arithmetic, that's overkill. But for specialized applications, time, angles, navigation, astronomy, base 60's divisibility advantages outweigh the memorization burden. Professionals in these fields learn the sexagesimal system and use it fluently. This is why we have a hybrid system. Base 10 for general use. Base 60 for specific applications where its mathematical properties shine. The Babylonian influence extends beyond clocks and props in navigation. Latitude and longitude use degrees, minutes, and seconds, all base 60. When a GPS tells you your position is 46 N, you're using Babylonian mathematics. Computer scientists recognize base 60's value. Some systems use sexagesimal for representing fractions precisely. The factorization properties that made it useful in ancient Babylon make it useful in modern algorithms and in music. The division of octaves into intervals reflects mathematical ratios that the Babylonians would recognize. The mathematical relationship between musical harmony and number theory has ancient roots. The persistence of base 60 tells us something profound about mathematics and culture. Good ideas transcend their origins. The Babylonians are long gone. Their language is dead. Their cities are ruins. Their empire collapsed millennia ago. Yet every human being on Earth uses their mathematical system multiple times daily. This is the power of elegant mathematics. It doesn't care about politics, religion, or culture. If it works, it survives. The Babylonians discovered mathematical truths about divisibility and practicality. These truths remain true regardless of who discovers them. Mathematics is universal. Base 60 teaches us that mathematical thinking means optimizing for your needs, The Babylonians needed easy division for trade and commerce. They needed precise astronomical calculations. They needed a system that worked well for measurement and geometry. They didn't choose base 60 because it was natural or obvious. They chose it because it solved their problems elegantly. This is real mathematical thinking. Identifying the properties you need, then finding or creating a system with those properties. When you face a problem, don't assume the obvious solution is best. The Babylonians could have used base tenet, would have been simpler in some ways, but they thought deeper, identified what really mattered to visibility, and created something better. Next time you look at a clock, remember, you're looking at 4,000-year-old mathematics. Every second that ticks by is a reminder that good mathematical thinking is timeless. The Babylonians gave us a gift that keeps on giving. They showed us that mathematics isn't just about calculating, it's about designing systems that make calculation easier. They proved that taking time to think deeply about which system to use can create benefits that last millennia. If you're fascinated by how ancient civilizations shaped our modern world, subscribe to Math's Whisperer. We're dropping daily episodes all season, exploring mathematical thinking, ancient wisdom, and modern mysteries. Tomorrow, we're entering the legendary Library of Alexandria to discover what mathematical treasures burned with the ancient world's greatest repository of knowledge, and what we lost forever. Hit subscribe, ring that bell, and comment. What other ancient Babylonian influences do you see in daily life? Let's keep exploring mathematics together, one whisper at a time.